Hi everyone, I am Shamanta MS, Assistant Professor from Physics Department at Maharaja Institute of Technology. Today in this session I am going to introduce and explain the first module. So that first module is what we know, that is module first is oscillation and waves. So in that first we will study what is the oscillation, how the oscillation will takes place, and what are the main thing required. It is working on which principle, that oscillations, and what are the things important things include, and how these oscillation will affects and useful to the engineering field. Okay. And these oscillation waves are classified in different types of oscillations. So that different types of oscillation we will study, and what are the applications of that oscillations, and then problems, how we used to apply in a problems, and whether how we used to observe in our daily life this type of oscillations. So all this we are going to study in this. So first we know if the particle is moving from one position to the other position, then for that we used to call as a type of motion. And then what types, whether if it is moving in a straight, then we used to call as a translatory motion, right. So because the motion of a system, the motion of a physical system can be classified into different types, that is depending upon how the particles are moving. Okay. So if the particles are moving in a straight line, then we call as translatory motion, right. So then translatory motion will come, periodic motion, oscillatory motion. So this all we used to observe, and this all in physically also we used to observe this, because this all will come under classical mechanics, right, or we can easily observe through our naked eyes. So that we are going to study in this module first. So that is oscillation and waves. So in that particularly we are studying oscillations. Okay. So then so I said that the motion of a physical system can be classified into mainly the translatory motion, a particle which moves in a straight path, linear motion. So that type of motion we used to call as the translatory motion, where we used to observe. So a person is straightly moving on a road, okay, a train moving on the track. So a ball is moving on the ground, the particle which moves in a straight line. So all that particle motion we called as the translatory motion. So that translatory motion means if the motion of a particle varies linearly with the time t. So if the motion of a particle varies linearly with the time t, so that type of motion we used to call as the translatory motion. So that the example, so we can give the train moving on a straight track. Okay. So this is best example we can give. So the next is oscillatory motion. To understand this oscillatory motion in simple harmonic motion, the mainly thing we have to first understand the that is periodic motion and oscillatory motion. Periodic, to understand the simple harmonic motion. First, to understand the simple harmonic motion. To understand the simple harmonic motion, first required is periodic motion. So what it says that a periodic motion, a motion which repeat itself after a regular interval of time. So that is called periodic motion. So means when we used to observe, that we used to observe in the clock. Okay. So when it is when the hour hand, minute hand is rotating, so after 60 minutes the hour hand will come back to its same position. Okay. So that means after some time interval that hour hand will come to the same point. So that type of motion is called as a periodic motion. Okay, hour hand, then hour hand, minute hand, like that. So if we consider a clock, the best example, that is clock. Okay. So if we observe in the clock, that is minute hand, hour hand and seconds hand. Okay. So this hour hand, if we indicates that hour hand, now suppose it is at the point of, now at the 2, okay, 2 o'clock. So after 60 minutes that hour hand will come back to its same position. Similarly, after 60 seconds the minute hand will come back to its same position. Okay. So like that the hands will move. So that type of motion we call it as the periodic motion. So a periodic motion is nothing but the motion which repeat itself. After a regular interval of time. So the motion which repeat itself after a regular interval of time. So that type of motion we used to call as the periodic motion. So example, so here we can see that is a clock, that is the hands, the movement of the hands in the clock. So that we observe what is the hour hand. So after 60 minutes the hour hand will come back towards the same point. So after 60 seconds the minute hand will come back to the same position. So like that we used to observe the best example, and like that. So example, one more example, example 2. The center one we consider, that is a sun. Earth in the orbital path. So Earth will rotates around the sun. So for every 365 days the Earth will come back to its the same position. So at that time the velocity, acceleration will be remain same, and what is the displacement and all. So here this is also in periodic motion. After some interval of time the Earth will come back to its same position. So, these two are the best example for the periodic motion. So we can consider like that. So if we leave any object, so that if we hold the rubber band and leave it, it will reaches the extreme point and again it will come back to in the same position, but that is not the example for periodic motion. Why? Because it is not coming in the same path. Here the what happens, it will not come back in the reverse direction. Okay. So it will not making a oscillation, here it is making a only the periodic motion. Okay. So what is then that the oscillatory motion? What it says that? So that is somewhat different. So oscillation motion next. Oscillatory motion. What it says that motion? The motion of a body which makes a to and fro motion about a fixed reference point. Okay. That means after travelling of some distance, then the particle will come back to the same position in the reverse direction. So that is what we called as the oscillatory motion. A body in periodic motion which will execute a to and fro motion. Which executes to and fro motion about a fixed reference point. About fixed reference point. That means if the particle, if we consider any particle, so that particle will travel some distance. After traveling some distance, again it will come back in the same path. Okay, so that what we call the to and fro motion about the fixed reference point. If we can about a fixed reference, the best example, the motion of a bob in a pendulum, and the springs, the spring which is attached with the mass. So example, motion of a bob and a pendulum. So like that, if we consider one end is fixed and the another end is freely falling, so this will make an oscillation like this about this fixed point. So this is the, suppose this is a fixed point. Okay. So if we consider this is a fixed point, then this bob will make a to and fro oscillation. It will move and reach the extreme point and again it will come back in the same path. So that type of motion we used to call as the oscillatory motion. So similarly in like that example, another example, if we observe a spring which is attached with the mass, spring which is attached with the mass, so this also it will move some distance, it will, and again it will come back to in the same position, and it will travel some distance and again it will come back to same point. So that is why it is in the periodic motion. Okay. And so similarly, if we will take a potential valve, example, another example, so potential valve, if we drop a ball from the one end, then it will move about the fixed reference point and again it will move for some distance and again it will come back in the reverse direction, okay, through the reference point. So here also the particle is moving for some distance and again it will reaches the extreme point. So, like that it is oscillating. So, that is why this is in periodic motion and also as well as in oscillatory motion. But here in this case what will happen, this is in periodic, this is in periodic motion, periodic. But if you observe, this is not a oscillatory motion. Why? Because earth is not making a to and fro motion, it is going in the same path, okay, and it is not coming back. So, that is why this is not in oscillatory, not in oscillatory. Not in oscillatory, and same this also in periodic, this also clock also in periodic motion after some interval of time repeats, but that hands is not making a motion in the reverse, okay. So, it is not making the oscillation, oscillation is nothing but there must be a to and fro motion, okay. So, that is why this clock also is not a oscillatory, is not a oscillatory, only this is a periodic in nature. So, that is why all the periodic motion is need not to be a oscillatory, but all the oscillatory motion is all the oscillatory particles is in periodic nature, okay. But that is changes in the damping cases, because damping means when the amplitude will be goes on decreasing. So, due to some disturbance, so at the time it is in different case, but here if we consider this case oscillatory motion means there a periodic is the oscillation as well as in periodic nature also, okay. So, here also oscillation, it is making a to and fro motion and it is in periodic nature also. So, that is why all the oscillatory motions are in periodic nature. So, that is why we can conclude that in this all the oscillatory motion are in periodic nature, but oscillator need not to be in oscillatory except in the damping case, because it will varies, that we will get to know in damping cases. So, except in the damping cases. So, that is why we can say that all the oscillatory motions are in periodic nature, but all the periodic motion need not to be in oscillate except in the damping cases. So, then what are the causes, main things to cause the oscillations? So, the causes of so if it must be oscillate, it makes oscillation means it mainly depending upon the two properties. So, that is inertia and elasticity. So, inertia we know that is so body continues in a state of rest until we are applying the external force on the body. So, the particle is until at rest. So, when we used to apply the force on that, then it starts its movement. So, that what we used to call the inertia, and it is depending also on the elasticity. Also, what are the causes of oscillation? causes of oscillation in a system, it is mainly depending upon the two properties. So that one is inertia and the another is elasticity. So what its inertia says that, so every body continues in a state of rest states of rest or of uniform motion until applying the external force. What elasticity? So what it says that elasticity, when the spring is attached with the some, there is some elasticity will take. So what is that elasticity? The property of a body which is having a tendency to gain its position after removing the external, regain its position after removing the external. The property of a body which is having a tendency to regain its position after removing the external force. So that is elasticity, what it says that. So we can, the property which is having a tendency to regain its original position after removing the external force. So that is, suppose now we will consider a spring which is attached with the mass. So spring which is attached with the mass. So when we used to apply the force on it, then what will happen when we used to apply the force? Then there is a changes in its dimension, whether it may be expand or it may be compress about the main position. So what will happen? It will expand. So this is in the form of elongation. When we used to compression form. So that from the main position here the displacement is elongated and here the body will be compressed. So through a displacement X. So mainly here the force which is acting, that is restoring force. Restoring force F is equal to minus kx. So that negative sign which indicates that the restoring force which is acting opposite to the motion of the body. So that negative sign. So that's that elongation and due to compression. So that negative sign. And where k is the proportionality constant and x is the displacement. So and the acceleration, what will happen acceleration here? So in this, when the body is oscillating, so if we place a body about the center to the fixed point, so initially the displacement will be 0. So initially the displacement will be 0 and at this point initially the velocity will be maximum. Velocity will be maximum and the acceleration is also 0. But when the body will displace from the initial point, so then what will happen when the body is shifted from the mean point, when the body is shifting from the mean point, so then the displacement so here the acceleration is always directed towards the mean position, whether it is in negative direction or positive displacement, but the acceleration is always directed towards the mean position, but opposite to the displacement. Suppose here the displacement will be in positive, then the acceleration will be negative. The displacement is negative, then the acceleration will be positive, the opposite. And the extreme point, at the extreme point the velocity will be minimum. At center the velocity will be maximum. At the extreme point the velocity will be minimum or 0 at this extreme point. Velocity will be minimum or 0 at this extreme point. So totally it is depending upon the main properties of the elasticity and inertia. So based on the oscillation will takes place from the mean position. So when a particle initially at the state of rest, so at the time the velocity will be maximum and the displacement will be 0, and after moving some interval of time, extreme point, then when it is at extreme point the velocity will be minimum, and when it will turning takes place it will make a to and fro oscillations. So that is in the positive direction or in maybe in the negative direction, but acceleration is always directed towards the mean position. So that force is directly proportional to the negative of the displacement. Means the restoring force which is acting on a body, that is in the opposite direction, opposite to the displacement, and acceleration is also directly proportional to the displacement. Acceleration is also directly proportional to the displacement, but that is in the opposite direction, whether it may be in suppose the displacement will be positive, then the acceleration will be negative, vice versa. So this is the causes of the oscillations we used to observe. And the SHM is mainly next we are going to study the mechanical oscillations. So that is very important, that is simple harmonic motion. So the next concept is simple harmonic motion. The heading itself indicates that this is a simple, very simple to and fro motion will takes place. So it is a very special type of oscillation. It is a special type of oscillation So it is a special type of oscillation in which the acceleration always directed towards the mean position. Always directed towards the mean position. Directed towards the mean position. So it is a very special type of oscillation in which the acceleration is always directed towards the mean position and its magnitude is directly proportional to the displacement about a fixed point. About a fixed point. So that fixed point is so what will happen when we used to consider a body? So that is make a to and fro oscillation. That will make a to and fro oscillation. But in this, acceleration is always directed towards the mean position. Whatever the displacement will happen, so but the acceleration is always directed towards the mean position and its magnitude is directly proportional to the displacement. So what are the magnitude we used to consider? That is directly proportional to the displacement. So what is the extreme position that is to displacement, positive or negative? So and this is about the fixed point. So what fixed points at this point, or it is called as a fixed point, it is called as a center of oscillation. Center of oscillation. So it's a fixed point is called as center of oscillation. So it's always directed towards the and the magnitude is directly proportional to the displacement. So that means if we consider it is mainly the simple harmonic motion, any motion that is works on the Hooke's law. So that if we consider force is directly proportional to the displacement, so that is in opposite direction, and its magnitude, so that magnitude is also directly proportional to the displacement. If we take any magnitude, that is directly proportional to the displacement. Then what are the characteristics of simple harmonic motion? Characteristics of simple harmonic motion. So simple harmonic motion So then what are the characteristics of this simple harmonic motion? So one is it is in periodic motion. That means after some regular interval of time, the motion which will repeat itself. Yeah. Also this is in periodic motion, means which will repeat itself, and also it will execute say to and fro motion. So it is in periodic nature also, and it is oscillatory also. Okay. So it is in periodic motion, and the acceleration is always directed towards the mean position. Is always directed towards the mean position. Acceleration is always directed towards the mean position. So, and the restoring force which is acting on a body, so that is in opposite direction. Is in opposite direction. So what is the force that is which is acting, that is in opposite direction? So so that's why this negative sign indicates that the force which is acting on a body is in opposite direction. So that will indicate this negative direction. When the body will displace it, when displaced from a mean position, when displaced from mean position, the restoring force is trying to bring the body back to its mean position. When a body will move towards the extreme point, then that restoring force which is acting on a body, it will try to bring that body to its mean position, initial position. That force, the restoring force which is trying to bring that body back to its mean position. So these are the characteristics of the simple harmonic motion. So one, it must be in periodic, it must repeat itself after a regular interval of time, and the restoring force which is acting on a body is in opposite direction, that is opposite to the displacement, for this displacement. So that's why force is done. And when displacement from mean position, the restoring force is trying to bring the body back to its mean position. So these are the characteristics and the definition of the simple harmonic motion. So based on that, next we are going to find out the differential equation for the simple harmonic motion. So then what are the differential equation and what is the solution for that a simple harmonic motion? So that we have to find out.